I'm going to talk today primarily about the new distributed AllegroGraph 7.0, but also do a little bit about Gruff 8.0 in the browser. So let me click. Yeah. So I'll start with just to get your appetite whetted with Gruff 8.0 in the browser and tell you how to, if you want to play yourself, how to get to the free AllegroGraph or the Enterprise Edition on AWS. And then most of my talk will just be about distributed AllegroGraph. We were very fortunate that we've been working with a bunch of customers and partners that strongly believe in the new trend for data-centric computing, yeah, a movement where you don't get a new application for every new question, but where you try to live with one semantic model of all the things you care about, and then one big data infrastructure based on that semantic model. And we at France have specialized in a specific implementation of data-centric computing that we call entity event-based knowledge graph. Having said that, then we're going to talk about AllegroGraph and how it actually supports both data-centric computing and these entity-based event-based knowledge graphs. But first, about Gruff 8.0. So I looked to the participant list. I saw a lot of people that already have played with AllegroGraph. And for the last 10 years that we had Gruff as a standalone version, I got the same question. Can we please have Gruff in the browser? It's so hard to install AllegroGraph locally. Well, it's not hard to install it, but my company won't allow it, my IT department. So we finally ported the graphics layer of Gruff to HTML5. And now the same code base runs the standalone version and the Gruff JavaScript version. Yeah, and to our surprise, it's actually in many ways faster than the thick client, mostly because all data copying between Gruff and AllegroGraph happens locally in the server. So let me just give you a quick introduction. So if all goes well, I'm doing this from home, so I'm almost certain that things will go wrong here. No, the service is still up and running. That's great. Let's go to the browser here. Let's do from localhost. So here's the view of the new AG Web view that some of you might know. We have a different page for the catalogs and repositories, but just for this demo, let's go to one of the repositories that we have, the healthcare repository. So now we're in AllegroGraph 7.0, and the new thing is this button here, yeah, explore healthcare, explore this repository using Gruff. And I start it up. And here we see in the browser an almost identical version, well, actually an identical version to Gruff. Yeah, I can do all the things that you guys probably already know how to use. So I can display some triples, yes, here, and I have my triples. I can do any rendering that I want. I can double click on the trial and I'm in the tab view that I can browse through. I can go back. Oh, by the way, usually I hit the F11 button so that I now have the full screen. I can throw away all my triples on the screen. I can still do my free text indexing. So let me get something with aspirin and cancer. And here I select some trials and I can still do everything that I did before. So I can look at some diseases. I can look at some drugs. And I can look at some side effects. Yeah. And if I wanted to, I can still look at all the predicates that I have in the system. I can select them. I can do my regular shortest path if I get lucky. Oops, let's put it in the middle. Yeah, and I can start doing this. So all the things that worked before still work. Yeah, I can do my regular thing with romantic kissing. There's one amazing clinical trial. Oh, I don't know which one it was. Is it this one? brief title. No, that was this one. So I'm looking at a clinical trial about the effects of romantic affection on blood chemistry and immune parameters. Basically, it says the more romantic you get, the better your immune system works. And then I can do the shortest path, and I can try it. So let's do here, and let's see if I can find a link between this and this. And just like always, yeah. And even building queries still works completely in the view, so I can do something like this and this and this and this. And I can copy it to the query view here and here. And I could say, let's take this into variables. Again, I'm doing this very fast because I know a lot of people in the audience already know how to use Gruff. All I want to show you is it's a complete copy of the standalone graph that we normally have. So here's the automatic sparkle that gets created, and here are the results. I can always still edit here. Run my query, so I can do that. I can create a visual graph. Anyway, I personally think it's almost like a miracle that the engineer that did this managed to port something that worked on Windows and get a complete identical copy in HTML5. So that's all I wanted to show about the graph in the browser. Now I'm guessing that some of you want to play with it yourself. So let me go back to my presentation. It's here. Yes, so I'll leave this in the slides here. You already saw this. So if you feel the urge to try it out, we now have in 7.0 also AllegroGraph Enterprise Edition in the Amazon Marketplace. So you can just go there, start up a machine, and then start running AllegroGraph. So we, again, something that many customers wanted, and we now made it finally happen. It makes life for us also easier. But if you want to run it locally, you still can do that. So if you go to allegograph.com downloads, then here you get our download page. Yeah, again, here is the regular download for AllegroGraph, and you can see that you can run AllegroGraph in Linux using RPM or just as a tar file. You can play with AllegroGraph in Docker, and you can get a virtual machine that you can run it from, or you can go down to Gruff, and let's go in here. So let me click on this. So here are all the standalone versions for various systems. There's a Sparkle endpoint, and we'll give you a password if you want to go to other Sparkle endpoints. Then use this password for the month of May. You can play with that, and we have a bunch of files that you can play with to get started. Okay, so that's all I wanted to say about Gruff and the marketplace. Let me go back to my presentation. Okay, so that was a little bit of a commercial, but let's now talk about the thing we wanted to talk about this morning, and that is distributed AllegroGraph 7.0. Originally, we started working on that in a telecom use case with a telecom integrator called Amdocs, where they took all the data that they had about telephone customers hidden in hundreds and thousands of databases, and all brought it together in what they called the entity event tree. Yeah, the core entity was the customer, and then literally every action by the customer, whether it was a bill pay or a phone call or a call to the CRM center, et cetera, it all was attached to the one entity. So that was the first one that we started with. And then we started working with the Montefiore hospital in the Bronx about 5 years ago. Where the Parsime Haji, the project manager there, had the same approach. Yeah, take as your core entity the patient, and then everything that can ever happen to patient in the entire hospital lifecycle, and attach that event to the patient. Yeah, so without loss of any data, you can create a very, very simple data structure representing everything that happens to the patient. So, but for that, we had so much data that we had to develop a first version of distributed AllegroGraph, and it's now in production since 2017. It's been heavily tested. And after that, we're now developing use cases for the call center, in finance, and with the marketing company. Yeah. This approach only works if you really believe in data-centric computing. Yeah, so not a new app for everything. When you believe that you can actually do data-centric computing in this simplified kind of knowledge graph, used to entity event-based knowledge graphs, and you really have to believe in semantic technology, because all the things that I'm going to show you today won't work at all in a property graph model. Okay, so data-centric computing. I'm guessing a lot of people have heard of this. One of the leaders of the movement, actually probably the leader of the movement, is Dave McComb, who wrote several books, Software Wasteland and the Data-Centric Revolution. And here is a summary of his data-centric computing approach, where he says data-centric refers to an architecture where data is the primary and permanent asset. And applications come and go. In the data-centric architecture, the data model precedes the implementation of any given application and will be around and valid long after it's gone. So data is the core. Now, people already think, that they're doing this, but that's actually not the case. Businesses are in a hurry, they want functionality, and they purchase or build application system. And each application system has its own data model. Its code is inextricably tied with the data model, and it's extremely difficult to change the data model of any of the implemented application system. And to make matters worse, you literally have probably hundreds or thousands of these applications. I think that most of you guys in the audience already work in enterprises, so you recognize that. And so each application on its own has hundreds to thousands of tables and tens of thousands of attributes. And then they're all interfaced, kind of unstably interfaced. And there's a lot of data copying going around, but no one dares to touch then the core data system, just because any little change might break everything. So the data-centric approach is to turn everything on its head. There's one semantic data model that describes the core elements of your business. And then each bit of application functionality reads and writes through the shared model, where you have both the semantic model and all the instances embodying that semantic model. Now, I could talk about our telecom use case, but today I will mostly talk about the healthcare use case, where we have this combination of data-centric computing and an event-based knowledge graph. So for the last 5 years, we've been working with Montefiore, that creates a data analytic platform to advance patient care. It's heavily sponsored by Intel. We've been working on that all along. And again, the dream at the hospital was not to build more and more complex applications, more and more complex machine learning algorithms or whatever. The real dream was, can we take all the data, everything that happens to patients, and simplify it and put it in one platform, so that whatever new application you need to build, we can use the same underlying data model. And so this same underlying data model has been in use since 2017, when we went into production with a model for respiratory failure, where we have a random forest model with 46 complex variables that can do a way better job than doctors and nurses to predict whether or not someone is going to have respiratory failure. And it's kind of interesting that we had this model, because now in this day and age of COVID, this model has come to the fore, and the hospital is very close to releasing a new model that is very specifically aimed at COVID-19 patients. Anyway, so the underlying data model that serves respiratory failure is also used for sepsis detecting, or finding if people have a spinal cord cancer and spinal cord compression, but used for outpatient appointments, or to do malpractice research, or anyway, lots and lots of use cases, and these are only a few, there's many more. The core is one data model, many different applications. Yeah, and the data we have is incredibly complex. Most people in the audience will have seen this picture before. Usually, I like it so much. It's made by Parsa, this picture. Here you have a patient like me that generates so many different types of data. I communicate with the hospital. There's a Fitbit that I might have. We know your genetic makeup. We know your family tree. There's things in your body that generate data. The hospital has Epic as this big elephant in healthcare with 40,000 columns and God knows how many tables. Yeah, there's an ICU of things in the hospital that generate data that needs to go into our entity event graph. There's test data, there are image data, and I don't want to belabor the point. Yeah, it's just a lot of data and humongous. And the point is, can we take all that incredibly diverse data and put it in this one simplified model? Yeah. Now, again, I alluded to it several times. So what we do is we basically flip the data 108, well, I would say 90 degrees from how it is right now in relational database tables. Yeah. So we kind of think it's normal that one single patient might be in the enterprise data warehouse in 4,000 tables and 20,000 columns. Yeah. And IT people will just laugh at you if you say, hey, can I get all the data for Jan's Haasman? They say, well, I can't write a query like that. And of course, I mean, for any person to really get familiar with the enterprise data warehouse, yeah, as just one data source, I mean, it's an incredible task to figure out how to get even some data out of it. And what you guys also know is that hardly anyone ever does direct data science on top of an enterprise data warehouse. So we flipped the data around. We said, okay, we choose one core entity. In healthcare, it's the patient. In telecom, it's the user. And then everything that can ever happen to the patient becomes an event, where an event is a very simple data structure. Yeah? It's just an object with a start time and an end time and a type. Yeah? The type could be a vital sign or a diagnostic or the outcome of a test. So that is the type. And then you have a few other key value pairs that describe it. But the core shape of every event is entirely the same. Okay. So this is a summary. So entities and events and sub-events, by the way, are represented as hierarchical trees. Then very important for us is that we group these entity event trees together. So for people in the audience that are familiar with semantics, we use or the fourth element of every triple for a patient or for a telephone customer, yeah, and make that the entity ID. And because we have one index for the fourth element, we can, with one call, get all the data for that particular patient or customer out of the database. And we don't have to use the fourth element. For that, we also have the thing called triple attributes that I'll talk about a little bit later. So you can also use that to group patients together, but you have to choose one of them. But then they are basically grouped in the database. So if you have almost 2 million patients, one second. If you have almost 2 million, if you have almost 2 million patients, then or you can look at it as one huge graph, or you can look at it as 2 million individual trees. Yeah, and then another thing about our trees is that every tree terminates in a knowledge base. Yeah, and that knowledge base can be an enterprise taxonomy, the ontology, thesauri that describe the important concepts in the tree, and all kinds of other domain knowledge. Yeah, so for example, in a hospital, that knowledge graph would also have all the metadata about doctors and departments and policies. Okay, so here are some examples of how we represent this. So a lot of people in the audience might have seen this before. Yeah, you have the core entity, which is a person. This person had an outpatient encounter at this particular date, and he also had a sub-event of type patient diagnosis, which is value allergy to peanuts, which is an ICD-9 or ICD-10 code. This object this ICD-9 code, which is reality, is linked to then a mapping object that then goes to, in our case, 180 different life science taxonomies that we've all integrated. And so this allergy to peanuts is linked to SNOMED, allergy to peanuts, which is then has many more abstraction levels going up. So allergy to peanuts is a subclass of allergy to legumes, which is a subclass of food allergy, going all the way up. And for those people familiar with graphs, if I want to find all the people that have allergy to peanuts, I just go back and find only one ICD-9 code. If I have asked for food allergy, I'll probably find 400 ICD-9 codes and find way more people. And if I ask for everyone in the database with an allergic condition, I probably get 75% of all the data of all the patients. So this is the actual data. I try to simplify it a little bit to give the principle again. So this entity, if you look at and squint your eyes and you look at our model, you see there's always one core entity. Then there's this event graph with encounters and demographics data, where even, by the way, demographics are events because people change genders and they change addresses and, well, whatever you can think of. And then events always terminate in knowledge bases, taxonomies, ontologies, and it could be statistical knowledge, could be PubMed, whatever you can think of that is important in a hospital. Same thing for a telco. You could have a core entity here. You can have event graph where you have various types of events, and events, well, you have a from and a to, so you can see this is the starting person, this is the core entity of the tree, here are the events related to it. But one thing that all these people have in common is that they live in a certain place and we know that place. And so for us, the knowledge base, for example, is geonames. So the same model, whether it's for healthcare, telco, it's the same entity event tree. Now, what are then the benefits of this entire approach? Well, first benefits is that it is incredibly easy to understand our model. If you would have to go to an enterprise data warehouse in a big telecom or in a big hospital, it would take you weeks and months to figure out where all the data is. But I want to bet that I can take anyone in this audience, and within an hour, I can explain you where all the data is, how to read it, and actually do queries in Gruff to do whatever you need to do. So if I want to find all the people that had, say, gallbladder calculus after the year 2010, well, I would just draw this query on the screen, click a button, and here's the little sparkle that gives me an answer. Whereas if I wanted to do the same query of find all the people with gallbladder calculus after 2010, this would be part 1 of 3 in the enterprise data warehouse. I'm not making this up. This is really 1 out of 3 of a real query to get that answer. So that is the first benefit. So it becomes incredibly much easier to get data out of your knowledge graph. The second thing is to make it very easy to get the 360 view of your patients. So I told you earlier that we gave every triple in the patient tree or in the customer tree the entity ID. And that allows me then to do a simple query that says select star from the graph for this particular patient, and then give me all the triples. And then I click on this, and then within a second, I get all the data about the patient. Now, obviously, this is not very helpful for application developers. So we also have additional APIs. So in Python, I can just say import my library, connect to the big database, and then I say, give me all the data for this particular patient. And this data will be then a dictionary object. Well, basically the data comes back as JSON, and Python will turn it into a dictionary object. And when I pretty print that data, I get all the data, and this is fake data because this is about me living in this particular area. I'm actually female, I see in this particular data, but you get my point, An application developer only has to say, give me the patient, and I have the patient in the dictionary object, and now it's very easy for an application developer to get going and to build any kind of thing you want to do on top of that. All right. Then another benefit is you have to do only a one-time mapping in ETL procedure. Yeah, there's no, so because the target ontology of the events and the entities is relatively small, all you have to do is to go to any complicated database, figure out where the table and the column that you need, and then create a mapping. But let me first talk about something else. So people, when I talk about this approach, people always say, oh, but it's so much work to get all the data in. But the beauty of this system is that you can start with low-hanging fruit. You don't have to take all your data and put it in the knowledge graph. You just look at your use case and start importing those elements that you need for your use case. Because this is you don't have to change the data model ever. Yeah, only when you get new types of events, you might have to add new types of events to your ontology. But you never change the shape of your data. So you can start with the simple use case and then slowly keep expanding, and then maybe reuse the data that you use for other applications later for other use cases. I hope I made sense here. Then another big benefit that we see here is that we have provenance at every level of the knowledge graph. Yeah. So for example, if you take this particular person that had an outpatient encounter, then this is the main event, the encounter. And we will have a bunch of metadata that describes on what day we imported it, from what data fields it came, from what database, and when we did it. And if we have a sub-event like a patient diagnosis, then again, we will have for this thing the date, when we imported it, and from what database, from what table, and from what column this particular element came. Yeah? So in the database that Montefiore has, I would say almost 75% of the data is provenance data, which is kind of makes it a lot harder to keep your queries fast because there's so much dark data. And we actually have now an approach where you can take the provenance data and put it in a separate database next to your original database and federate it to. And I'll talk about federation in a minute. Yeah. And then one more thing, one benefit, we can secure every triple in our entity event graph. We have a technology called triple attributes where you can add a JSON object with key value pairs to every triple that you add to your knowledge graph. Yeah? For example, just this very, very simple example, person 1 has diagnostic 1. Medical record number for this person is this, the security level is 8, and the department is pediatrics or cancer research. Now, oh yeah, what I forgot to say is these triple attributes both apply to triples. The triple attributes can also be assigned to users. Yeah? So what I can do with these triple attributes is I can write security filters. Yeah? Where I can say, well, I can only see a triple if the security level attribute of the user is higher than the security level attribute in the triple. Yeah? Or I can see only the triples if the user department, yeah, is a member of the triple department. Yeah? And then when I do a query, then the application layer will look in LDAP or any other system to find the core triple attributes for that user, and we'll add it as a prefix to the Sparkle query. So in this case, we'll say, well, security level of this person is 2, and the department is administration, and then this person has no chance in hell to ever see anything in about the bipolarness of a particular patient, yeah? Just because the security level is too low and he's from the wrong department. Anyway, again, I hope that makes sense. And then the final benefit of this entity approach, I've talked about it several times now, is we group all the patients together. So that also enables horizontal scaling through sharding. Yeah? So as I said before, you can use the fourth element of the triples or the triple attributes to group patients together, but you can then also use it as the sharding key, and that will enable distributed AllegroGraph, yeah? Where we have this new patented approach that we call fed shards. Sorry for that name. Yeah. where we do a hybrid of a distributed database with shards, where each shard gets federated with unshardable knowledge bases. Yeah, so the entity event tree goes into shards with the entity ID as a shard key, and then the shards get federated with non-shardable knowledge bases. Yeah, so let me just for a second say something about AllegroGraph Federation. There's many types of federation, and I recently gave a talk where I distinguished 7 ways to do federation with semantic graph databases, but for now, let's just keep it simple. Yeah. So in AllegroGraph, I think it's fairly unique. We can open multiple repositories at the same time as if they were one database. And then we have virtual cursors that issue get triple to each repo. Yeah. So that Sparkle doesn't even know that it's talking to multiple sources. So just for fun, say you have DBpedia and GeoNames as sensors sitting on the same machine or different machines, then I can open the database as a federated store, and then Sparkle can do queries against this federation. And Sparkle doesn't even know it's talking to 3 databases. Yeah, it will just do queries and it will get data back. So the example query that I always do is, what is the median income of the area where Barack Obama was born? I usually get some jokes about Kenya, but okay, in this case, what does my query do? Yeah, it goes to DBpedia, find Obama's birthplace in the GeoNames ID, then find in GeoNames the GeoNames ID within 10 miles of the place above, and then find in the census database the median income above 16 years and older for each of those IDs. Yeah? So if I do a quick demo of that, I could do it live. We have this functionality for many years now. So I'm opening multiple databases at the same time. Yeah, census, DBpedia, and GeoNames, and I open it, click on Start. And so now I have a database open with 1.6 billion statements. And then I do a query. And I do a query, and 1 second, let me, yeah, sorry. I wanted to stop it. Okay, here, let's see here. So here's the query, where in this query, I actually use 3 databases. First, I find Barack Obama in the DBpedia, and I find the GeoNames for the place where he was born. And I go into, I ask for the location for the place where he was born, and then I use a magic predicate to find all the places within 10 miles of that place. Then I want to check if it's a populated area, and then I get all the other places within that space, and then I go to the census database and find all the people in that particular area. And then I continue, and I click on execute, and I do the query 2 times. I click on it, I do it 1 more time. Yeah, and then within 600 milliseconds, I get this answer. Yeah. So I put the slides in here so you can see what I actually did. So forget about it, but you'll get this presentation later, and then you can kind of see what we did. Okay, so this was something we call federation, and we had it for the last 5-6 years. Yeah, but this is an important part because this we really needed to implement AG 7.0. Yeah. So imagine this: you have lots of patient data or customer data. Yeah, and you sharded your data. So each, in our case, say each shard has say 80,000 patients. Yeah, so you have, this is one machine that you see on this one screen, and say we have 6 shards, just an arbitrary number. Then, and on that same machine, so this is, yeah, each shard has a unique set of entities, but then on each machine, we also have 1 or more knowledge bases that cannot be sharded. Yeah, so this could be a terminology system, this could be statistical knowledge, this could be some metadata about important elements in the hospital. And we create a federation between each shards and these knowledge bases. Yeah. So, and because all of these things live in the same memory space, yeah, we don't have to put these knowledge bases in each shard, but we can keep them separately on each of these machines. And then this is how it looks like. You have multiple servers. Each server runs one AllegroGraph. Each AllegroGraph has a set of shards and a set of knowledge bases, where these knowledge bases are replicas. So we use our multi-master replication to actually have one place where we can maintain these knowledge bases and they can replicate at each of the servers. And then when we do Sparkle, the Sparkle queries get sent to each of the federations, and then it gets the result back. We don't send one of the secret sauces in this whole part is how do you manipulate your Sparkle queries so that you can get the most efficient way your data back. So we manipulate the Sparkle queries before we send them to each of the shards or to the federations, get the results back. Usually we have stripped out the aggregation beforehand. So when we get all the results back, for example, we do our aggregation later. A lot of complicated things. Let's not talk about it for today. Yeah. And then, so how does this work? Does it really make it possible to do scalability? Well, we've done a lot of testing with this, and let me just give you one simple example of what we did with this. So say we have patient data, then we worked on a cluster consisting of 8 nodes, and each node had 256 gig of RAM and lots of spinning disks, very slow. Each node in the cluster, each server runs on one AllegroGraph server, and per server we had four shards. Yeah, each shard contained about 550 million triples, so we had 70.7 billion triples in total. So this is one part of the experiment, and then we had a very fast machine, a supermicro with 500 gig of RAM, running entirely on fast SSDs. And there we had a single repository containing all patients plus the terminology system. However, we never could do 17 billion triples on that one machine. So we deleted all the Provenance triple, leaving us with about 4 billion triples for the patient data that we needed for our queries. Yeah. So it's a little bit unfair even that the cluster had to deal with many more triples than the fast machine had. Yeah. And then we used a bunch of queries that are relevant of various types of complexity. We did one query that says, okay, how many patients did we lose from 2010 to the year 2011? There's a medium complexity query, but some interesting union joins and filters. One query said, hey, give me all the demographics for all patients, which is a lot of joins, but low complexity, or give me all the diagnostics for all the patients that I have in the database that had at least one event. Again, this query returns a lot of data, but low complexity. And then we had a very complex, where it's almost like a complete ETL to copy everything in the patient data to a comma-separated file. So this is a very complicated query. And then if you look at the results, then here you see that if we did, say, the attrition query on one shard on one of the machines, yeah, it's only 1/32 of the data, yeah, you can do the query in 4.8. If I would put the same query, just again, one machine in the cluster, it would be 5.8. But if I did the query on the entire cluster, it would take about 7.2 seconds to do the query. Yeah? And this query returned only one result, which is the count of how many people we lost. If I ran this same query on the supermicro, yeah, it took 609 seconds. So if you take the ratio, then you see that the cluster was, in this case, 84.6 times faster than the supermicro. Yeah? So in this case, a real huge speed up. If I look at the demographics data, then the speed up is only 35 times, mostly because we had to return so many strings that we lost some of the speed up because all the data had to be streamed to the single master for the query. For diagnostics, we returned 69 million diagnostics. Yeah, so that was even more strings. And still, the cluster is 21 times faster. Or if I copy the entire database, we found that using this complex ETL, yeah, with the Sparkle query more than 400 lines, yeah, the cluster is still 32 times faster. So that was a really really good results for using the cluster approach. Yeah. Or I told you before about a model that we use for respiratory failure. Well, this query needed, this is a result that we did about a year ago, 38 queries, yeah, to fill the vector so that you can do your random forest model. Well, this shows that if I do all these 38 queries against one AllegroGraph, it takes about 200 seconds. And if I do it in one query after another. If I do it in parallel, so I run 4 queries at the same time, yeah, I can do it in like 80 seconds. And if I run the queries in 8 processes against one AllegroGraph with all the data, yeah, it would be like 50 seconds. But if I use a distributed version with 96 partitions, yeah, I can get it down to about 20 seconds. Or if I run then multiple queries at the same time, I can get it down to 6 seconds. Yeah. And we have a monitoring system in here where you can actually look how it works, but let's skip that for today. But again, I always urge you, when you do anything with AllegroGraph, with your queries or loading, always look at this screen to see how well your system is doing. Yeah. And then let me now come to the conclusion, because it's 45 minutes now. So we've been testing this for a while, and this is a quote from our partner at Montefiore, yeah, where he calls AllegroGraph 7 support of entity event data modeling a very welcome innovation in addition to our arsenal in reimagining healthcare, implementing precision medicine. I'm not going to read the whole quote to you because I'll leave it in the presentation for you. So let me just go here, yeah, and conclude with, if you believe in what I talked to you today about the data-centric computing approach and entity event knowledge graphs, and you believe in the semantic approach, then try it out for yourself, call us, and we get you on your way with how to model this. And then finally, I didn't want you to play with Gruff while I was talking, but we also, you don't have to install anything. We have a demo server at gruff.allegograph.com:10035. And there's already a small data set loaded, and you can start playing with Gruff in the browser right now. Okay, thank you very much for your attention.